Good evening to everyone and welcome to the SPM Revision Seminar online. And today's subject is physics. Before I introduce to the speaker, anyone who would like to ask a question answered by the speaker, please post your question on the chat box so we can read them out during the Q&A session. Besides that, for the Form 5 leavers, this year we're offering School Achiever Scholarship Awards (SASA). We do highly encourage all Form 5 leavers to submit your application through our webpage. If you want more information, please log on to our webpage to find out more. Today we have Mr. Eilham, a lecturer from the Faculty of University of Foundation Studies, as the speaker for today. I will hand it over to you, Mr. Eilham. Over to you.
Thank you very much, Mr. Mohan. Okay. Hello, students. Welcome back to our class. Okay. All right. So today we are going to cover. Today is our 5th week. We are going to cover our 5th chapter, and this is going to be our last chapter for Form 4. Okay. Before next week, we are going to start covering chapter from Form 5. Okay, and I believe most of you guys are going to have your physics trial question this week. So I wish you all very best of luck. Okay. All right. So without further ado, let's start with our slides. Okay, I have prepared some slides for everyone. Okay, so this week's topic is going to be light, and I need to say that in this chapter is actually quite general. Okay, I cannot really focus on only one topic or two, or actually this chapter is very huge. Okay, so the main things that we are going to cover for this week is actually, okay, let me continue. Okay, all right, so the things that we are going to cover in this week is actually this stuff. Okay, so let me get my ink. Okay, so we are going to cover reflection. Okay, so we are going to cover reflection over here. Oops, sorry. Okay, so we are going to cover reflection. All right. Okay, should be able. We are going to cover reflection for today. And then after reflection, we are going to cover mirror. We have 3 types of mirror: flat mirror, convex mirror, concave mirror. And then after mirror, we are going to cover refraction, law of refraction. And after that, we are going to cover lens. Okay, so we have 2 types of lens, which is convex lens and also concave lens. Okay, after convex and concave lens, we are going to then cover total internal reflection. Okay, this one is a very interesting topic. And other than this, okay, we have also the application part. Okay, so application part, I actually encourage you to do some self-study, because there are quite a lot of application that you can actually cover. Okay, so the application part, this one is very actually quite big, so I cannot really just focus on 1 or 2 application. Okay, we can talk about some application, but we cannot cover all application from all items. Okay. All right. Okay, so first thing first, let's go for law of reflection. Okay, so I think everyone should have learned law of reflection at some point. Okay, law of reflection is the very essential geometrical law. Okay, this is not really a law for light. This is actually a law for geometry. Okay, so assuming, let's say we have a light. Okay, this is a light. This light is going through a plane. Okay, this is a mirror over here. So according to law of reflection, this light will be deflected. It's going to be reflected back, such that this is going to be this angle over here. This is called as incident angle. The incident angle will be equal to the reflected angle. Okay, so the key idea is that you have angle of reflection equal to the angle of incident. Okay, so this is the law of reflection. You can see over here in this experiment, probably I can zoom in. Okay, hopefully you guys can see this. Okay, we can see light going into this what I call mirror, and then it goes reflected back, and the angle you can see very sharp angle. Okay, this is 0 until here. This is 30, 40, 50 degree. Okay, so the angle of incident is 50 degree, and then the angle of reflection you can see 0, 10, 20, 30, 40, and 50. So 50 degree. So angle of incident equals to the angle of reflection. Okay, so I think in bahasa Malaysia this is called as darjah sudut. Sudut. I actually don't remember the name. Sudut. Okay, never mind. Okay, I actually forget the terms already. Okay, so next we are going to cover these 3 types of mirror. These 3 types of mirror, this one is actually the first one, the plane mirror, is actually quite easy, but for the concave and also for the convex, you need to know several details. Okay, so concave and convex, they are going to produce different kind of image depending on how you place the object in front of the mirror itself. Okay, so let's go first. Okay, so first we are going to look at plane mirror first. Okay, so this is our plane mirror. You can see plane mirror is given by this straight line. Okay, all plane mirror should be a straight mirror. If the mirror is bended, if it becomes some sort of spherical mirror, then it won't work. Okay, it is not a plane mirror anymore. Okay, so I believe this is the kind of mirror you used to have in your house. Okay, so what is the characteristic for the image formed by this kind of mirror? Okay, you can see if this is your object, okay, this over here, this is your object, you can see that you are going to have quite a few incident ray. Okay, this incident ray is going to be straight onto the mirror and it's going to bounce back. Okay, so in this case, the angle should be 0. Okay, the incident angle equals to the reflected angle. So incident angle 0, reflected angle also 0. Okay, so for this case, if you look at the second line, this line over here, this is the incident angle. Okay, and if you want, you can have this ray going back. Okay, this is reflected, the ray is reflected according to our refraction, law of reflection. So incident ray angle equals to reflected ray angle. So geometrically, you will have some sort of image formed at the back. Okay, some sort of image formed at the back. Okay, so certain some terminologies that we can have. Okay, some symbol that we can use over here. The distance of the object to the mirror, distance from object to the mirror, this is called as U. Okay, U. So U is defined as the distance of object from the object to the mirror. Okay, and then the distance from the image to the mirror, okay, distance from image to mirror, this is called as V. Okay, V and also U. Okay, all right. Okay, next. Okay, sorry about that. Okay, so now next we have if we look over here, okay, if we look over here, we can see that the image is going to be at the same size. Okay, this is the thing that we want to take note. It is at the same size, it is at the same distance. So the distance U just now, U should be equals to V. Okay, the distance U should be equal to V. Okay, the image is going to be produced at the back of the mirror. Okay, back of the mirror. This is the front of the mirror. Okay, so this is U, this is the mirror, this is the front of the mirror, this is the back of the mirror. So image produced at the back of the mirror, this is called as virtual image. This is not real image. Okay, so virtual image over here. Okay, so one thing that you want to keep note, this is upright. Okay, virtual, and then this is upright, meaning that it is as the same position as your object. It's just that you can see if you ever sit in front of the mirror, you might recognize that if you put out your right hand in front of a mirror. On the mirror, the image is going to be showing you a left hand. Okay, if you put up a right hand in front of mirror, the mirror will actually give you left hand. So this is called as left right reversal. Okay, so this is one additional value that you can have from a plane mirror. Okay, right. So things that you need to know, how you can obtain this image. The second thing that you need to know, what is the U and V, what is the distance? Their distance should be equal. Okay. Third things you need to know is the image characteristic. Okay, given this is the object, what sort of image you can actually obtain from this plane mirror. Okay. All right. Next, we have concave mirror. Okay, so concave mirror image will be determined by the distance of the object. Okay, so this over here, we have a concave mirror. How can you remember a concave mirror? Concave mirror will curve in. Okay, so concave will curve in. Okay, so this is how I usually remember my stuff. Okay, I usually remember it by having the concave to be to be, where's my eraser? Okay, concave is usually curving in. Okay. Okay, so eraser. Okay, my pen. Okay, so things that you need to know when you have a concave mirror is this thing. Okay, this F over here, this is called as focal point. Okay, focal point. And then this C, this is actually the center of curvature. Okay, so how come you have a C over here? Okay, just imagine if you have this concave mirror. If you draw a circle, okay, if you draw a circle all around this mirror will actually become a spherical circle. Okay, and this C will actually be the center of that spherical circle. Okay, so that's why we have a C over here. Okay, all right. Okay. Okay, so things that you might want to jot down, okay, you might want to take note is that this F, okay, this F, this is the focal distance, okay, focal length. This R is the distance, the radius from the center to the concave mirror. Okay, all right. And one more thing that you might want to take note is that if a light ray pass through this concave mirror, okay, if a light ray pass through this concave mirror, okay, the light ray will actually go in. Okay, it will actually go in. Okay, so this is just some random light. Okay, so it will actually go in. Okay, so this is called as converging mirror. Okay, meaning that the light ray is going to converge to a point, given that this is the mirror that we have. Okay, all right. Now, what kind of image can we obtain from a concave mirror? Okay, so let's try and imagine that. Okay, so this is the picture that we can have. Okay, this is the first situation number 1. Okay, so this is a situation where you have an object at infinity. Okay, meaning that this object is very, very far away, very far. Okay, so as this object is very far, the light image is the light ray, this is the light ray, is going to pass through such as they are parallel. Okay, such as they are parallel. And once this light ray pass through our mirror, concave mirror, this light ray will converge into F. Okay, it will converge to F, this point F just now that we talked about. Okay, but sir, how can we know that how can we be sure that it's going to go to F? Okay, look over here. This is the law of reflection. Law of reflection dictates that the angle of incident equal to the angle of reflection. Okay, so according to this, okay, we can have this kind of geometry. Okay, this is going here, this is going here. This is the geometry stuff that I mentioned just now. Okay, and the same is going to happen at down here. It's going in this way, going back this way. So the geometry, angle of incident, angle of reflection, is going to always come to point F. Okay. All right, so what kind of image can we obtain if this is the case? Okay, so this is our object. Our image is not going to be an image actually. It's going to be a convergence of light. Okay, so example for this kind of cases, example that I used to have is that, for example, you have the sun. Okay, this is the sun, and then you have a concave lens, a concave mirror. Concave mirror. Okay, and then you have a piece of paper. Okay, so assuming that this sun is very far away from our Earth. Okay, it's going to go to this concave mirror. Okay, and then this concave mirror will actually converge the sunlight, and it can be used to burn up this paper. Okay, so that is one example that I can give to you. Okay, all right. Okay, now let's look at this situation. This is our second situation. Second situation over here. Okay, so now this is our center. This is C, center. This is our focal, F, focal. Now, let's assume that instead of having our object to be very far away, we have our object right here. Okay, what is this location actually? This location is known to be the object to be more than the center. Okay, meaning the object is very far, is actually more than the center location. Okay, so this is our object. Now, how would you actually draw the image? Okay, how can you actually draw the image? Okay, so remember three things when you want to draw a ray diagram. Three things. First things that you need to draw is the light ray going to the plane, and then it goes to the focal point. Okay, this is number one. Light ray straight, and then reflect, and then pass through focal point. Okay, so this is our first light ray. Okay, this is the first one. Now the second one is you can have a light ray passing through the center. This is light ray passing through center. And once it passed through this center, it is going to be reflected back. Okay, it's going to be reflected back. Okay, the third one is going to be when you have the ray going through the F, and then it get reflected back. You can also have something like, I will show you the example later. Okay, all right, so this is the kind of this is the kind of light ray that we can have. You can see the first one, this one, it goes to the plane, it goes to the mirror, and then it goes from the mirror, it goes to the F. The second one, it goes straight to the C. Okay, so you will have this, this is the converging point, and then this is our image. Okay, all right, so what is the kind of image that we can actually see over here? Okay, so this image is at the front of the mirror. Okay, so this is the front of the mirror. So this kind of image, we call it as real image. Okay, meaning that the image actually exists in front of the mirror. Okay, and then what other characteristic we can see? Okay, this object is quite big. This image is quite small, so we call it as diminish. Okay, it become smaller, diminish. Okay, and then this object is upright. This object is inverted. Okay, so this is called as inverted object. Oh, sorry, inverted image, not inverted object. Okay, so this is inverted image. So it is real, it diminished, but then it is inverted. Okay, all right. Next, we have this. This is the third situation. Third situation over here. This situation is when your object is located exactly at the center. Okay, this object is located at the center over here. So now what will we have? Okay, so again, using the same principle, the light ray should go to the mirror and then it go pass through the F, the focal point. Always remember, the first thing that you need to do when you have mirror is that you need to let the light ray go to the mirror, pass through the focal point. That's the first thing that you always need to do. Okay. Second things, if other than it goes straight, it can also pass through directly. And once it passed through directly, it can also bounce back. Okay, reflected back. Okay, so this is going to be our okay, it's going to reflect it back over here. And the third one, okay, remember we have three characteristics. The third one is when our object, it goes past through C. Okay, but then this image, this object, it cannot go past through. The light cannot just go straight down. Okay, it doesn't make any sense. So we just take 2 out of the 3 characteristic. Okay, we just combine this. This is a converging point, of course, but this one is much more greater converging point. Okay, because this one, at this point, we can have this image over here. Okay, so what is the characteristic for this image? Let's see. Characteristic. Okay, so this image is at the front of the mirror, so it is real. Okay, and then other than that, it is inverted because you can see the object is going up, the image is going down, so it is inverted. And then what else? Okay, the object is of the same size. Okay, so you can have 3 types. You can have magnified, same size, or diminished. Okay, for inverted, you can have 2, inverted or upright. For real, you can have real or virtual. Real image will be at the front. A virtual object will be at the back of the mirror. Okay, all right. Okay, so this is the fourth situation. Okay, so if you see what I have been doing from my previous slide is I actually move this object much more closer to the mirror. Okay, I just move this object much closer to the mirror. Now we can see in this situation, our object is located in between. Okay, our object is located in between the center, center C, and also this is the object, and this is the focal. Okay, our object is located at the in between center and also the focal. Okay, so this is our object. Okay, so again, three principle. Okay, first principle, light goes straight to the mirror, goes back to the focal point. Okay, so this is going to be the light. Okay, the light ray. Okay, the second one, the light can go to the focal. It can actually goes back, no problem. Okay, the third one, it can go from this point, from our object, it can go straight to the center C. Okay, so we can use all these three mechanism to detect the image, and you can see that this is our image over here. Okay, this is our image. So this is our original object. This is our image. Let's discuss the characteristic. What is the characteristic over here? Okay, the characteristic for the image, again, this is real, but then this image is now inverted. Okay, inverted image. And then this image, this is a small image. This is a small object. This is a large image. So this is actually magnified. Okay, this is called as magnified. Okay, so most of the time I see past years, they are going to ask you just the most is three characteristics for the image. So if it's okay if you know this 3 only. Okay, all right. So this is the next. Okay, so last time we have C, the object is between C and F. Now we will look at what happened when the object is at F. Okay, this is I think number 5 situation, the 5th situation, when object is located at the focal point. Okay, so what will happen? Okay, so this is the object. Okay, use the principle, go to the mirror. From the mirror, it will go to the F, and then from the object, it will go to the C. Okay, and you can see actually these two lines, are actually parallel. Okay, these two lines are parallel. So what kind of image can we make from this kind of situation? This is image at infinity. Okay, the image will be at infinity. So this one is rather absurd, okay, because the image, you cannot really get it somewhere near our mirror. No, we can only obtain the image if the light ray goes to infinity. Okay, and you can imagine that the image is going to be magnified very, very much, because the light ray have become, it need to actually go and travel quite a long path, so it's going to be magnified. Okay, okay. So this is the only characteristic that I can think of. All right, and the next one, okay, this is at F. The last one, number 6, this is going to be object located at more than the focal point. Okay, the object, this is the focal point, this is our object. Okay, so if this is the case, all right, you can, for this, you cannot really just go straight and then go to the focal point, because this does not really work, because the light ray is going to be coming back to your object. Is going to actually not working like that. The light ray is not going to work like that. Okay, it cannot really touch the object back. So instead, what you can do is that you can move this to the center. Okay, this is the only thing that you can do from the 3 principles that I mentioned just now. Okay, then what can I do? What more can I do? This is when you can use the reflection law. Okay, law of reflection. You let this one go to the center, let it reflect back. Okay, the angle of incident equal to the angle of reflection. Okay, and from here, now you can actually converge this two ray diagram into one converging point. Okay, it can converge like this. Okay, so now this is interesting, because now the image is not real anymore. The image is now virtual. Okay, so it is virtual. And then the image, you can see the object is small, the image is large, so it is magnified. Okay, and then what else can we see? Okay, it is upright. Okay, it is not inverted, it is upright. Okay, right. So this is the actually the characteristic 1, 2, 3, 4, 5 until 5. The 5th one. Okay, so this is the characteristic based on the picture that I mentioned just now. Okay, so the first one, the ray is from infinity, and then the image will be okay, just in case if you miss it, this is the first ray. Okay, so the object is at infinity, the image is at point F. Okay, and then it is highly diminished, it is real and inverted. Okay, highly diminished meaning that you don't really have the image anymore. It is becoming a point already. Okay, and then 2nd, 3rd, and also 4th and 5th. I actually don't put the 6th one. Okay, you can put the 6th on your own. Okay, the 6th one, you can see the image is actually enlarged. It is become magnified. It is virtual and it is upright. Okay. All right, so you can see all the nature of image are real, meaning that all of the image is basically being created at the front of the mirror, except for this sixth example or 6th situation where we have the image to be at the back of our mirror. This is the only virtual. Okay, all right. Okay, so that one concave mirror, that one is for what you call this, that one is for converging, now we have this convex mirror. This one is called as diverging mirror. Okay, this one is very much diverge light. Okay, diverging mirror. Okay, so what is the purpose of this diverging mirror? The same as concave mirror, you can have the F. This is the focal point. This is the center. Okay, if we have the concave mirror will have the C and F at the front of the mirror. But now for diverging mirror, the F and C is going to be at the back. Okay, it's going to be at the back. So what will happen is that the light ray will shine on this mirror and then it will be reflected back. Okay, so how can we know? How can we know this? Always check for the angle. The angle of incident, angle of reflection will always be the same. Okay, and it will actually go through this F. Okay, F is going to be the diverging point. Okay, it starts from F and then it starts to diverge all the light rays. Okay, so this is from infinity. Okay, and assume that we have an object. Okay, assume that we have an object over here. This object, it goes past through C. Okay, always remember it goes past through C and then it should go past through F. Okay, so goes past through C and then again this one should be parallel. Okay, parallel to this mirror and then it goes past through F. Okay, but then it cannot actually go inside F, so it will go outside. So our image is going to be over here, very, very small. Okay, so this is our object, this is our image, and we can see that our image is actually very, very small. It become diminished. Okay, the size is diminished. And then again, both of our object is virtual. Okay, so highly diminished and diminished. And then the position, you can see the position over here. It is between the mirror and also the F. Between the mirror and also F, behind the mirror. So the position of the object at infinity, this one is between infinity at the pole. Okay, so what is the application of concave mirror? What is the application for convex mirror? Convex mirror, this one is usually used in road. Okay, for example, you have light from infinity. This allow you to actually check the road condition. Okay, so most of the time you have diverging mirror. If a car comes, okay, it will actually be detected. The car will be smaller in size, but you will know that a car actually is coming. Okay, so the thing about this convex mirror is that the image will always be upright, meaning that if you look at the image, okay, you will know, okay, that is a car. Okay, if the image is inverted, then your brain is going to have problem processing that image. Okay, you need to convert and those kind of things. Okay, so those are the three mirror: plane mirror, concave mirror, convex mirror. Okay, now we will look at refraction. Okay. Okay, so for refraction, this refraction phenomenon occurs when light slows down. Okay, the keyword is light slows down. Okay, so light is known to be the fastest speed in the universe. Okay, but this is only applied when light is at vacuum. Okay, if light is in water, then light slows down due to the density of the water. So as light travels through different medium, it will have different speed. Okay, so this is largely due to the medium density. Okay, so water have molecules and then light needs to travel in between those molecules. So it is basically understandable that light become much more slower. Okay. So this is an example you can see over here. A ray of light goes through. I am taking that this is a glass block. So it will become refracted over here. Okay, and then as this one finish, it will then go back. Okay, it will go back. So the angle is fairly different. This is the angle. This is the angle. Okay, this is the angle. Okay, so the angle will be different. So we are going to look at the connection between the angle and also how much the light actually deflected. What's the angle actually? Okay, so that is given by this Snell's law. Okay, Snell's law. So Snell's law is derived by geometry. Okay, I believe you guys don't actually learn this. This one is actually a syllabus from foundation. I just show it to you. The syllabus that you guys will use is this one: n1 sine theta 1, n2 sine theta 2. Okay, so n is called as the refractive index. N is refractive index. And then if we have n1 meaning this is in medium 1, medium number 1, medium 1. Okay, and if we have n2, this is actually medium number 2. Okay, you can see from this picture over here, we are starting from medium number 1, it goes to medium number 2. Theta 1 is at medium 1, theta 2 is at medium 2. Okay, all right. So most of the time for your level, you are going to have the easiest one is going to be this one is air, the other one is water. Okay, this one is the typical stuff for SPM. Okay, so refractive index for air is 1.0, refractive index for water is 1.33. Just in case if you don't remember. Okay, all right. So question might ask you, okay, given this light, okay, this light is passing through this air and then it got refracted by the water. And given the angle of the water, theta 2 is actually 30 degree. Okay, theta 2 is 30 degree. Find the value for theta 1. So how do you do that? Okay, I will repeat the question. Given that refractive index for air is n1 is 1.00, and then for water n2 is 1.33, and given that the angle on medium 2 is 30 degree, find the angle in medium number 1. How do you answer this? Okay, just use the formula n1 sine theta 1, n2 sine theta 2. What is n1? N1 is 1. This is the refractive index in air. Sine theta 1. Theta 1 is unknown. So theta 1. N2 is 1.33. Sine theta 2 is 30. Okay, so 1.33 times sine 30. Let me get my calculator. 1.33 times sine 30 degree. Make sure your calculator is in degree. Okay, how do you know that your calculator in degree? On the top of your calculator, it should says D. Okay, if it says R, then it is in radian. So change it first. Okay, so I have 0.665 over here. This is 0.665. Okay, this is 1 times sine theta. This will be sine theta. So this is going to be theta I is equal to the inverted arcsine 0.665. Okay, so what is that value? I get my value to be 41.68 degree. So the angle, if this is 30 degree, the initial angle is 41.68 degree. This one is 41.68 degree. Okay, all right. So this is actually very typical, and this is actually very common. If you don't know, if you don't know this formula, this one will be given in your paper. Okay, at the front of your paper, you will have that exam sheet, right? So sorry, the formula sheet. Okay, just take this one from your formula sheet. This one is available for you in your formula sheet. Okay, all right. Now we also have this thing. This is actually the actual depth divided by apparent depth. Okay, so what is this? Okay, given a phenomenon where assume that this is you. Okay, this is you. You are standing at this part. Okay, this is a pool, and then you see you saw a fish. Okay, there is a fish over here. Now you see the fish like this. Okay, this is your view. You can see the fish is over here, but the fish is actually not here. The fish is actually here, down here. Okay, all right. So what happened? This happened due to refraction. Okay, so you actually have this actual depth from this point until here, actual depth. This is d, and you actually have some apparent depth, small letter d. Okay, so in order for you to find the actual depth, you can just take n, refractive index, equal to the actual depth divided by apparent depth. Okay, this one is quite simple, and I actually did not find this that much in the syllabus, so I am taking that this one might not come out, but nonetheless I still cover just in case. Okay, so this is the formula. So the refractive index, assuming that this is water, refractive index will be 1.33. Okay, and then multiply with the apparent depth, you can get the actual depth. Okay, so this is how you use this formula. Okay. Okay, now this is the main thing. This is the main thing that you need to learn in light. Okay, which is convex lens and also concave lens. So first thing we have is convex lens. Okay, so this is a convex lens. Okay. This is the principal axis. Hopefully you know this. Okay, this is the center, O. And then you should have F, the focal. Okay, on both sides you should have a focal. The length should be equal. Okay, now unlike the mirror, in mirror you have C. Okay, in mirror you have C, but in lens you don't have C anymore. Instead you have 2F instead of C. Okay, you have 2F. 2F simply means that this is double the focal length. Okay, it's just double the focal length. Okay, so first we are going to look at convex lens. So for convex lens, this is a diverging lens. Okay, diverging lens. So if you have a light ray, assuming that you have a light rays pass through this convex lens, the light ray will actually converge into some point. Okay, it will converge into some point. So most of the time it will actually converge to a focal point lah. Okay, so I don't draw this because my drawing is not really that good. Okay. All right, so assuming that our light comes from infinity. Okay, this is the first scenario over here. When our light comes from infinity, it goes right through our lens. It will go through F. Okay, from infinity, pass through our lens, it will go through F. Okay, all right. So it's very hard, you know, drawing using pad. So this is the drawing that I can come up with. Okay, you can view this over here. Okay, this is our first picture. Okay, from infinity, the light ray go and pass through convex lens. It will converge to this point F. Okay, so what is the characteristic for the image? There's basically no image, you just get a point. So the image become very much diminished. Okay, very diminished. Okay, I think that's basically everything that you can have. Okay. Next, let's assume that we have this case. Now this case is much more interesting because now we have our lens over here, our F over here, 2F over here, and our object is located very near to 2F. Okay, it is big, but then it is not that far from the 2F. Okay, this is F, this is 2F. Okay, so how can we draw the image? Under what assumption should we draw the image? So as following the mirror, let the light, okay, let the ray pass through the lens, and then it goes pass through F. Okay, always allow the light to pass through F. Okay, and then one more thing. Now this time you can actually allow the light to pass through O. Okay, let the light pass through O. Okay, so what will the image be if you do it properly? If you do it properly, the image will look like this. Okay, it will become like this. This image is inverted, meaning that it become upside down. Okay, inverted. Inverted. Okay, and now the image is over here at this point. So now, in contrast to the mirror, to the mirror, if your image is located over here, this is actually a real image. Okay, let me check. Okay, this is actually real image. Okay, so you will have a real image inverted, and also the image will actually be I think the image will actually be at the same size. Okay, it will be at the same size as the object. Okay, so same size. Okay, so what are the things that we can talk about? Okay, you can also talk about the distance. This is the U, this is the V. Okay, so the distance we can see the U is bigger than V. The distance from object to the lens is bigger than the lens to the image. You can also talk about that one. Okay, all right. Now the next one we can have. Do I have any time? Yeah, I have 10 more minutes. Okay, I will try and finish up this and this before we go. Maybe you can try do the last two. Okay, so at this point, okay, when you have your object located at 2F, okay, so you have our convex lens over here, focal point 2F, focal point 2F. Okay, make sure that this F, they are at the same distance. This 2F is twice the distance. Okay, 2F. So you have your object over here. So let it pass through. Let it pass through F. Okay, as usual, pass through F, pass through O. And actually, this is going to be symmetry. Okay, this is going to be symmetrical. This object, this is the image. The image is inverted. Okay, it is inverted, and then it will be same size. Okay, it will be same size as the object. Okay, and then this is going to be a real image because this is over here. Okay. All right. Next one we have the fourth situation. Now again, just as what we have in our mirror, we are just moving around this this object. Okay. So let's move this object around. Move this. Okay, so move. So instead of the object having a 2F, now it exists in between 2F and F. This is 2F. Okay, so again, always the same method. Let the light ray pass through the lens. The lens will pass through the F. And now from this object, it will pass through O, and then it will go until here. Okay, so now you can see that this is the converging point. Let the object become here. Okay, this is the image. Okay, this image is going to be this is going to be the image. So let's look at the characteristic. Okay, this image is basically very big compared to the object. It is magnified, and then it is over here, so it should be real. Okay, and then what else? This is inverted. Okay, inverted. And then if you look at the distance for this one is actually less compared to distance from the lens to the image. So U is actually less compared to the compared to the V. Okay, distance of the object to the lens is less compared to lens to the image. Okay, so this is the characteristic. Okay, do I have any more time? Okay, 8:55. So I will let you try and do the other two situation. Okay, this two situation is rather easy, so I will just let you try them yourself. Okay. Next one, we are going to look at concave lens. And concave lens, this is actually quite easy because you only have one type of image that is going to be produced. Okay, what is the image? If you get a light from infinity, okay, light coming from infinity, this is going to diverge. Okay, so convex lens, just now this is converging lens. Then concave lens is going to be diverging lens. Okay, so all light passing through this lens is going to be diverge out. Okay, it's going to be diverge out. So how do you draw the image? Assuming that you have an object, assuming that this is your object, let the object pass through the diverging lens, and let the light diverge. Okay, diverge in, it will diverge. This one will also diverge out. Okay, so this is the object. It's going to be the same typical object. It's going to be diminished, meaning it's going to be smaller in size, and then it's going to be virtual. Okay, because this is at the front of the lens, so it cannot actually exist in real life. Okay, in reality. And then one of what else? Okay, so this is also upright. Okay, one more thing I forget. This is upright. So the object is up. This one is also up. So it is not inverted. It is upright. Okay. All right. So this is the thing that I think most of you guys are familiar with. Okay, so I have only one thing that I want you guys to try and look. There is a very specific experiment involving this lens formula. Okay, so we have 1 over u plus 1 over v equals to 1 over f. U is distance between object to lens. V is distance between image to lens. And then f is the focal length. Okay, so what I want you to do is look back at this experiment. Okay, you are usually going to have this kind of experiment where you have a light source, okay, light source, and then you will have some sort of object over here, okay, and then this is a lens. Okay, this can be a concave lens or a convex lens. Okay, and this is a screen. Okay, this is a screen. This is the object. Okay, so what you will do is that you are going to play around with this screen. Okay, you play around with V. U is going to be fixed. So given different type of lens, you are going to have different type of V. Okay, so look back at this experiment at school and then try to look at all the variables and all the data. Okay, because I predicted that this one is very famous for paper 3. Okay, this is going to be one of the question for paper 3. Okay, I cannot really give you like a question, an exact question, but I'm telling you that this is worth your time to actually check. Okay, and I believe most school will have this kind of experiment. Okay, so try and look at it back. Okay. And then last but not least, we have total internal reflection. Okay, so total internal reflection, this one I actually enjoy teaching my students. Okay, this occurs when the light travels between more dense medium to less dense medium. Okay, so before this we have refraction. Okay, refraction occurs when light travels between medium. But now what happened is that if light is traveling from a high density, this is low density. Now something interesting will happen. Okay, light when it travels, okay, light, when it travels between different medium, it can be two things. Okay, first thing, it can be refracted. Second thing, it can be reflected. Okay, so those are characteristic of light. Light can actually be refracted and reflected at the same time. Okay, so it's just that the intensity will be decreased lah. Okay, all right. So what will happen is that total internal reflection will happen given that the light pass through this medium at this very critical angle. Okay, meaning that, okay, maybe I can erase thing. Okay, so if the angle is less than critical angle, so the light can actually be refracted. It can also be reflected, both. Okay, but given at certain critical angle, the light is not going to be reflected. The light is not going to be reflected. Okay, not refracted, not reflected. Instead, the light will actually pass through this surface. Okay, so this is 90 degree. Okay, what happens if you go more? Okay, if the angle is more than the critical angle, this is going to be a reflection inside. Okay, total internal reflection, meaning total internal reflection, meaning instead of the light being refracted, it is going to be reflected back. Okay, so one of the application is in coaxial cable. Okay, cable, most of the internet cable use this kind of method. Okay, so this is very much similar as you have some sort of mirror. Okay, but you don't have mirror. This is just between two different medium. It's just that these two different medium, this one is higher density compared to this one, and then this one is striking at a more bigger angle compared to the critical angle. So this is the situation. Okay, so as usual, this is n equals to 1 over sine c. What does this imply? Okay, if you remember, n is equal to sine theta reflected divided by sine theta I incident. Now, at reflected angle, when this is critical, reflected angle will be 0. So sine 90 degree divided by sine, this is a critical angle, theta c. So sine 90 degree is going to be 1. So 1 over sine critical angle. Okay, so what does this equation do? This equation help you to identify the critical angle. Okay, given that medium, this medium is water. Okay, so water, the n is 1.33. Okay, so you should be able to find the critical angle for water. Okay, so once you get the critical angle for water, if the question asks you, how can you get total internal reflection? Just let the angle to be bigger than the critical angle. If you let the angle to be bigger than the critical angle, then you will get total internal reflection. Okay. All right, so this is the application part. You need to read each of these material, each of these item. Okay, microscope, how does microscope function? Telescope, camera, fiber optic, and also periscope. Okay, so microscope, how image can be formed given the image is very small. How can it be enlarged? Okay, understand the principle behind that. You will have two lens actually. The same goes for telescope. For telescope, you will have light. Okay, light passing through two different mirror. Okay, so from infinity. So how you can actually make a telescope better. For camera, understand how camera focal length can be adjusted. Okay, fiber optic, this one is for critical angle. Okay, this one is mostly used in total internal reflection. And the last one is periscope. Okay, periscope, this one is used in submarine. Okay, so this one uses the 45 degree to enable you to look. Okay, so this one I cannot really help. This one you really need to learn the concept for each item one by one. Okay, so try and go for the mechanism for each of these item. Okay, all right. So oh, it's already 9:05. Okay, so we will take a break, and after that, if you have any question, you can actually ask me. I will answer all your question. Meanwhile, we will take a break for a while. I will let Mr. Mohan. He will take the session for the time being. Okay. All right, Mr. Mohan, back to you.
Give me a second. Okay, Mr. Eilham, it's over to you now.
Okay, all right. Thank you, Mr. Mohan, for that brief break. Okay, so let's look at the question that we have. Okay, we have Daniel from Sabah. Okay, sadly I'm from Sabah and there won't be any trial. Okay, so sad to hear that. I'm actually not sure if it is good for us to actually have trial in our current situation. So best of luck for Sabah, and I believe everyone from Semenanjung will be supporting you guys from behind. Okay, with our prayers and stuff. Okay, so the question. Oh, what this one is interesting. This one was asked by the great Albert Einstein. I don't know if this is a fake account or what. Okay, let me publish this. The well, Einstein actually asked, "What is light?" Okay, this is a very interesting question. If you actually see what I have presented. Let me okay, never mind. Okay, so if you actually see what I have already presented, the presentation is based on the idea that light is a wave. Okay, so light is a wave. Then as a wave can be reflected, it can be refracted. Okay, there is a characteristic for wave. But if we take that light is not a wave, light is a particle, for example, light is a photon, then most of those things is going to break. Okay, the idea from that classical idea of light is going to break. Okay, so the question of what is light, I don't really have any definitive answer. What I can answer is that light is a wave, and light is also a particle. That's basically what we understand right now. Okay, so thank you for Albert Einstein for asking that particular question coming from Einstein himself. Okay, next we have what if I say the image is fake instead of virtual? Okay, so the notion virtual, virtual, it refers to fake. Yeah. In a context, virtual refers to fake. Okay, but when we have like virtual reality, we don't really consider them as fake reality. Instead, we acknowledge that they are fake, but they are some sort of useful for us. Okay, so I'm not into English that much. If you want English, you can come to tomorrow class. Okay, but for the time being, I think we should stick with virtual, because the answer scheme will have virtual instead of fake. Okay, so this is a question. Okay. Next, we have what if I use Snell's law formula that you shown. Okay, so Snell's law formula, let me show you the formula. PowerPoint, this is the Snell's law. Refraction. Okay, so this is the Snell's law. Okay, the Snell's law actually is this is the general Snell's law. Okay, so Snell's law it is basically derived from geometry of the light ray. Okay, so if you want to use the Snell's law, you can just take this equation, plug in the value n1, theta 1, and 2, theta 2. Okay, and you plug in n1, theta, and 2, you can get the angle or stuff. Okay, so this is essentially if you can see, I actually give you in 3 equation. So this is the first equation. You can also have this and this. Okay, this and this, they can make up a second equation, and then this and this can also make up a third equation. So somehow this equation looks like one equation, but you can actually split them into 3 different equations. Okay, I believe that you guys are actually good. You guys can actually figure out a way to actually split this one equation into 3 equations. Okay, all right. Okay, so stop sharing. Okay, so I guess that's all the question that we have. So any other question? I think no more questions. So I guess that's it from me for this week. Okay, I will meet you guys again next week. Next week we will start covering chapter 5. Okay, so chapter 5, Form 5, chapter 1, first topic. Okay, so stay tuned for next week. And for tomorrow, you will have class with English teacher, our Miss IS. Okay, so stay tuned and stay safe. Okay, all right, so back to you, Mr. Mohan.
Thank you, Mr. Eilham. We have definitely learned a lot, and hopefully we all have a clear thought about this session. And that's what Mr. Eilham said. And tomorrow's session will be English by Miss Ashwari from 8 a.m. onwards. So thank you, everyone, and I'll see you tomorrow.